Derivatives of Inverse Functions by Melaine Sitt. So the goal of this video is to gain a better understanding of more complex problems. So what you should already know is that g prime of x equals the inverse of f of x, which should also equal 1 over f of prime of g of x. On the right side is the general proof. So we have x equals f of g of x, and we're going to take the derivative of that. That's going to equal 1 equals f prime g of x times g prime of x. And if we divide each side by f prime g of x, that should leave us with g prime of x equals 1 over f prime of g of x. So in this slide are the trig proofs. On the left side, we are proving the derivative of the inverse tan function, which should be equal to 1 over 1 plus x squared. We start off with y equals inverse of tan x, and so that should also equal tan y equals x. So now we're going to take the derivative of that. The derivative of that is secant squared y times the derivative of y equals 1. So if you divide each side by secant squared y, you should be able to have the derivative of y equals 1 over secant squared y. Now we're going to use the trig identity to replace secant squared y. So secant squared y should equal tan squared y plus 1, and we're going to substitute, which you should get 1 over tan squared y plus 1. And if you recall earlier in the problem, we have tan y equals x. So we're going to substitute, and you should be able to have 1 over x squared plus 1. So on the right side, we're going to be proving the derivative of the inverse cosecant x, which should equal negative 1 over x times square root of x squared minus 1. We're going to start off with inverse cosecant x equals y, which actually should equal cosecant y equals x. So we're going to take the derivative of that, and that should be negative cosecant y times cotangent y times the derivative of y equals 1. If we divide both sides by negative cosecant y and cotangent y, that should leave us with the derivative of y equals 1 over the negative cosecant y times cotangent y. Now we're going to use the trig identity, which is 1 plus cotangent squared y equals cosecant squared y, and we're going to isolate cotangent y, which should be the square root of cosecant squared y minus 1. So we're going to substitute that, and that's going to leave us with the derivative of y equals 1 over negative cosecant y times the square root of cosecant squared y minus 1. Now, if you recall earlier in the problem, we had cosecant y equals x. So we're going to substitute all the cosecant y's with x, which should equal the derivative of y equals 1 over negative x times the square root of x squared minus 1, which is what we should actually have. So for our first problem, it's going to be f of x equals x to the power of 5 over 3 times e to the power of x to the power of 2. And we have to find g prime of e. So we're going to set the equation of x to the power of 5 over 3 times e x squared equals e. So x is going to have to equal 1, which means that f of 1 equals e and g of e equals 1. Now we have to take the derivative of f of x, and we're going to use the product rule. So that's going to be x to the power of 5 over 3 times e to the power of x to the power of 2 times 2x from chain rule, plus e to the power of x to the power of 2 times 5 over 3 times x 3 over 2. And that should simplify down to 2x 8 over 3 times e x squared plus 5 over 3 times x 3 over 2 times e x squared. So now we have to plug that all into g prime of x. So that's going to equal 1 over f of prime of g of x. And once we plug in e, so g prime of e equals 1 over f prime of g of e. And so we know that g of e equals 1, so we're going to substitute that in to equal 1 over f prime of 1. Now we're going to use f of x, and we're going to substitute 1 into that equation, which we should get the final answer to be 1 over 2e plus 5 over 3e. So for our second question, we have f of x equals 10x plus arctan x squared, and we're asked to find g prime of 0. So we're going to set up the equation of 10x plus arctan x squared equals 0. So x can only equal 0 to satisfy the equation. So now we can assume that f of 0 equals 0 and g of 0 equals 0. So now we have to find f of prime of x. And that should equal 10 plus 2 arctan x times the derivative of arctan x, which is 1 over 1 plus x squared, which we found earlier in this video. So now we're going to plug that into g prime of x, which is 1 over f prime gx. And now we're going to plug in 0. So g prime of 0 equals 1 over f prime g of 0. And we already know that g of 0 is 0. So we're going to substitute that in, and which is 1 over f prime of 0, which equals 1 over 10 times 2 arctan 0 plus 1 over 1 plus 0 squared, which should equal 1 over 10. So for the third and last question, we're given that f of x equals 7x cubed plus ln x cubed, and we're asked to find g prime of 7. So we're going to set up the equation of 7x cubed plus ln x cubed equals 7. Well, x is going to have to equal 1. So f of 1 equals 7 and g of 7 equals 1. So now we're going to have to find the derivative of f of x, which should be 21x squared plus 3 times ln x squared times 1 over x. And so now we plug in 7, g prime of 7 equals 1 over f of prime of g of 7 equals 1 over f prime of 1. And if we substitute 1 into f prime x, which should be 1 over 21 times 1 squared plus 3 ln 1 to the power of 2 times 1 over 1 should equal 1 over 21.